Hello students, welcome to lab number 3. At the end of this lab you will do assignment number 2. Just as a quick recap, in our last lab we did some super basic things like recap how to load in data, how to look at it, how to do basic manipulations, basic visualizations, and then we looked at some logical operators. If you're not quite comfortable with those things yet, might be a good time to go back and watch lab number 2 again and get your bearings, because we're going to build on that today and do more complex things like summarizing and aggregating. And it's really helpful if you know how to use things like functions and read-in data and stuff like that. Today we're going to do mainly 3 things. First off, we're going to learn how to recode variables. If you remember from our lecture, there are many different levels of variables, and sometimes we want to go from a higher level of the variable to a lower level of measurement for our variable. So for example, we may want to go from a ratio measurement like GDP to a nominal measurement like high GDP, low GDP. And so today we're going to learn how to recode our variables in that manner. And we'll look at some tools that we can use to accomplish that. Then, and here's where things get really exciting, we're going to start summarizing our data. So in the last lab, we looked at a data set that was pretty much already summarized for us. We didn't really have to do anything like collapse rows or take averages within groups and things like that. But in this lab, we are going to learn how to do that, because in addition to select, filter, and mutate, grouping variables and summarizing them is kind of one of the last 2 big things that you'll need to know to do real good in-depth analysis, right? You need to know how to take the average standard deviation and just count the number of observations in a given group. These are basic tasks of data analysis, and so we're going to learn how to do that today. Lastly, we're going to build on our basic understanding of ggplot and visualizations, and we're going to add a few extra shapes to your repertoire that you probably already know about. So by now you know geom text. We looked at kind of that percentage label, and geom column or geom col, which is the bar chart geom that we use, that rectangle. Today we're going to go over some other geoms, including point and line. Point is the geom that you use to make scatter plots, and we'll notice that these geoms, and secret, some of the other geoms we've already used, have other aesthetics that we can vary. So in lecture 2, I think it was, we talked about how an aesthetic is kind of any axis along which we can encode information, and that the x and y axes aren't the only axes along which we can encode information. For example, in a scatter plot, you can vary the size of a dot and stuff like that. So we'll look into that a little bit more. And then finally, we're going to learn how to do faceting, which is basically to take your plot and to split it into subplots based on some variable. In some sense, it's useful to think of this as another axis, or as another axis. At least when you're starting out, they're not exactly the same, but they're kind of close enough. And we'll show you what the benefit of doing that is. So why don't we get started with our code? Why don't we open up a new R script? Let's load. Oops. It's early in the morning today, so I'm a little bit slower on the pickup and am likely to make a lot more mistakes today, so bear with me a little bit. Let's do lab 3 script as we did last time, but today we're not going to be loading a data set in the traditional way. Sometimes R comes with built-in data sets, or they come built in with other libraries. So we're going to download a library that has the data set today, and it's called install, oh my gosh, packages, Gapminder. It's called Gapminder, and that's the name of the data set too. So it looks like I have to, let's go ahead and call Gapminder. And so one funny thing that you'll find here is that it looks like I'm calling an object, and I kind of am, whoops, but it's an object that only exists in the library of Gapminder. So I'm going to call Gapminder, and I'm going to assign it to an object that'll kind of permanently show up in my environments here. So let's go ahead and do that. And as we did last time, why don't we just take a look at our data set? We can see that it has 1,700 rows of 6 variables. Goodness, that is quite a lot. So why don't we just do head data and see what we've got here. So load data, always want to do comments. Comments are always a good thing to do to remind ourselves what we were doing at this point in time when we're looking back at our code, and look at the data. Okay, let's see. What do I got here? Okay, I have country, I have continent, I have the year, life expectancy, population. It looks like this is total population, and then GDP per capita. Okay, so these are useful variables, and we're going to do some manipulating with them, some manipulation. So, why don't we see what I guess I really want to see is kind of what's the range of the year variable. So I have multiple observations for example, Afghanistan, because I have one observation per year. So this is going to be a little bit difficult for a few reasons. Well, not difficult because we get more data, but I'm probably going to want to summarize this information in some way that helps to bring out some trends. So why don't I start by looking at one country. And as usual, I'll start off with my data. Actually, let's hold off on assigning this to a new object yet, because I want to make sure that my operations are correct before I do that. Right now, I think I'm only interested in life expectancy. So I'm going to select a few columns. Let's select country. And since I'm only going to be choosing Afghanistan, I'm not going to bother pulling in the continent, because Afghanistan is always coded as Asia, I'm going to guess. And if not, we'll look into that when we get there. Maybe I'll look at year. I'll pull in year, and I'm going to pull in life expectancy. And let's see what we get. Yeah, that's pretty much what I'm looking for. But you'll see, and it tells me that I still have like 1,700 more rows. Right? That is after the ones that it printed, right? So in total, these numbers add up to 1,704. But it showed me 10 of them, and it hid 1,700, basically, so that my whole console isn't filled with rows and rows and rows of data. Okay, now I want to filter down to Afghanistan. Okay, so it looks like these measures happen roughly every 5 years, starting in 1952, going all the way through 2007. Okay, so that's interesting. So it's 50 years of data measured once every 50 years. Why don't we go ahead and put this in a visualization object. So I just saved this as viz, and now if I pull viz, here's what I get. Just Afghanistan, right? Okay, so I'm not going to do any recoding or anything like that yet. Not yet anyway, but why don't we start off with some basic visualizations. At this point, it might be useful to look at a new type of geom. Whenever we're working with time variables, often we find that like a line chart works pretty well, right? We don't want to use a line chart when it comes to discrete categories because those things kind of aren't continuous, and using a line chart implies continuity in a way that categories don't really have. So why don't we start basic, right? We'll just call our ggplot line, okay? And then we'll think about, okay, well, on the x-axis, usually for a line plot, is the time variable. And in this case, that's year. And then on y, let's say I want to use the only other continuous variable I have, which is life expectancy. And then my geom is geom line, when I want to do a line chart. Very creative, I know, but it's probably for the best that they keep it simple. Let's run that and see what we get. Yeah, okay, perfect. That's pretty much exactly what we're looking for, right? We're looking for a line. I like to do something else too, right? That line looks a little skinny to me. So why don't we do something like increase the size of that line, make it a little bit more bold so that, you know, it's a little easier to see. And one thing to notice here is that I'm not putting size inside of my aesthetic, right? Note that size just kind of goes there on its own. And that's because size doesn't vary. It's not encoding any information. It's just a content. It's just a constant, right? So size, I just want to say, just turn the whole line a little bit thicker. And likewise, there are other things that we can change that won't vary across the line. For example, maybe I want to make the color red. So I'll just do that. I'll just say color red, and look at that, right? And the whole line turns red because it's not inside the aesthetic, right? If I did put color inside the aesthetic, I would then have to give it another variable to which I would want color to map onto, right? I don't want to do that, so I leave it as is. One other thing I like to do when I make line plots is to kind of put points, geom point, where those observations occur. So right now, if you look at the x-axis down here, it implies that we're taking measurements every 10 years. We know that's not the case. And so kind of what I want is I want to put dots where each of those actual measurements occurred. And so I'm just going to also add geom point on top of that. So they go in layers. First, it'll draw the line. And then on top of that, it'll draw the point. So let's do that and see what it turns out. Okay. Well, we can't see them. And that's probably because they're too small. So why don't we increase their size? Yeah, okay. I think that looks pretty cool. Why don't we stop there for now, right? And actually, if we really wanted to, let's not stop there. I lied. We're going to do this. We're going to add a geom text. And we're going to say the label equals life expectancy. Let's see what we get. And then again, we kind of have to do the vertical adjustment trick. And yeah, I think that looks pretty good. In this case, we might want a little bit more vertical adjustment. Yeah. Very cool. Very cool. So, you know, what is this telling us? This is telling us in general, and you know, last thing, let's just add a title with the labs command. So in labs, I can say, you know, for the title equals life expectancy in Afghanistan over time. And then I want to relabel my x-axis title. Here is kind of like a lowercase year, but I want to look professional and I wanted to say, you know, uppercase year. And on the y-axis, I'll say life expectancy. It labels these axes according to whatever your variable is, but those are pretty ugly right now. And so I want it to say something that makes a little more sense for the average viewer. So let's run that. Yeah, nice. Okay, there we go, right? So what are we seeing when we do this plot? Well, pretty simply, we've just kind of plotted the average life expectancy over time in Afghanistan from 1952 all the way to something like 1957. This is the total average life expectancy. And, you know, while we're talking about average life expectancy, one question to ask might be, you know, let's take a look at our data again. You know, we get life expectancy for all of the countries in our sample. And so it might be useful to see, you know, what was the average life expectancy? What was the average life expectancy across our entire data set at a given point in time? So what was the average life expectancy at year for all countries? So let's do that, right? First, we're going to start with our data, and then we're going to think, okay, maybe maybe I just want whatever the most recent country is, right? So kind of what we want to avoid doing when we manipulate our data is we kind of want to avoid hard coding numbers. So for example, if I only want rows where the year equals the highest year that we have, what I want to avoid doing, though it's not the worst thing in the world if you do, is to do something like this, right? That's not terrible. And I get what it is that I'm looking for, right? It's all, okay, yes, there are all the countries in 2007, terrific, right? What I really want to do is I want to have a more programmatic way of doing things. This way, if in the future I add years to my data set and I reload this data set, it'll automatically take whatever that maximum year is, right? So here I'm basically saying, okay, look in the year variable, dplyr, and whenever the year matches the maximum value in that column, keep those rows. Don't keep anything else, right? So if we did this on its own, for example, we could say max data year, and it would say 2007, right? That's basically, let's do that, same as above, right? So let's go ahead and do that, and you'll see that we get the same data set. But this way, if we go back and we change our data a little bit, which happens often, by the way, when you do research, then we still get what it is we're looking for. Okay, so, we have our data set. Let's go ahead and select just the variables I'm looking for. I'm going to select country, continent, and life expectancy. Let's run that and look at what we get. Okay, as I explore my data set more, I realize that it might be a little bit more useful to actually look at the average within continent. Within the continent. That is to say, in 2007, what was the average life expectancy for all of the countries in Asia, for all of the countries in Europe, for all of the countries in Africa, the Americas, and Oceania, right? And it's kind of unclear to me how I would do that with mutate, right? So if I just did, mutate, what would I even do here, right? If I said mean life expectancy equals, I don't know, mean life expectancy, let's see what we get. So that's kind of useful. Notice that all of the values in this new column that I just instantiated, that I just calculated, are exactly the same. They're all 67. And that's because what we've done with mutate is to say, look at this whole column right here and take the average of this entire column. That's useful, right? Because now we know that the average life expectancy for all countries everywhere is 67. And so maybe we call this something else, right? What is the total life expectancy? Actually, this is correct, right? This comment is correct. So we've done it. We've calculated the average life expectancy for all countries in 2007. But, I kind of want to know within continent what that number looks like. So what was the average life expectancy at year for all continents? Here's where things get a little bit more complicated, right? So again, let's go back and why don't we just copy some of this code so that we know kind of exactly what we're getting, right? So start with your data, filter to 2007, and then just keep those three variables. That's what we should be getting, and that's what we get by now, right? But now we want to summarize, and that means that our data set ultimately is going to go from like 142 rows down to some smaller number of rows. And so we have to think about what the unit of each of those rows is. What do I mean by that? The unit of observation, right? What is one observation in the data set? Actually, let's keep it simple. What's one observation here? Well, that's one row per country, right? But in our summarized data set, what we want, group by, is one row per continent. And that'll give us 6 rows in our summarized data set because nobody permanently lives in Antarctica, right? So group by, when we tell our group by, we're telling it, hey, the output of this next part is going to be smaller than everything that came above it because I'm going to want you to summarize things. So when you summarize, when you do the next thing that I'm going to tell you to do, I want you to summarize at this level, right? Because you'll notice there are many countries in Africa. Surprise. If you didn't know that before, now you know. Africa has many countries in it, right? And so when we're taking the mean life expectancy of all the countries in Asia, for example, we're going to want to put all of these into the same group, and that's what we've done by group by. Then we need to tell R how we want it to summarize. So right now, if we just ran with the group by, if we took this part out, nothing would really look different, right? Because we haven't told it to do anything yet. So summarize is a lot like mutate because we're telling R to do something, make some calculation, and save that calculation in a column. So I actually kind of want to know a few things now that I'm here, right? Since we know mutate can handle multiple arguments at once, maybe I want to know number of num countries. I try to keep my variable names short. Maybe I want to know the number of countries in each continent. And so this n, open parentheses, close parentheses function, it counts up the number of rows in each continent. So let's go ahead and run that first and see what we get. Okay. That's pretty useful, right? It's a different type of summary. We're not quite there yet with the life expectancy yet, right? But we're building to it. We're getting to that. But first I have, I have the number of countries in each continent. But I'm not done, right? What I want is average life expectancy. And now I'm just going to call this same formula that I did for my total average life expectancy, but since this one is after group by, it's going to run this same calculation for each one of these groups. So let's see what we get when we do that. Now, that's more like it. That's nice. I like that. I'm a fan of that. That's terrific, right? So not only do I have the number of countries, right? We made that column up here. We also have the life expectancy for that continent in 2007, right? And why don't we go one step further, and maybe I want to see the standard deviation of life expectancy in 2007. Okay, all right. Let's go ahead and save that variable, or save that data set. So, we did a few things here. Let's go ahead and tick some things off. Let's see, we did that. We did that. We did that. Let's just say we did summarizing. What else? Okay, we'll do that in a little bit. So, summarizing, super important and powerful way of aggregating your data And again, I have a very short attention span, so let's visualize this, right? And why don't we do a dot plot or a scatter plot, right? We've done a lot of geom columns. I'm kind of tired of geom columns. So we'll tell it our data. We'll go down to aesthetic. And on the x-axis, I want continent. On the y-axis, I probably want average life expectancy. And why don't we just stop there for now and make sure that our chart works? Yeah, okay, that works, right? And, you know, these titles look good enough for now. We got our point. But we have all this other information that I really want to encode, but I can't, right? Or rather, I can. I just don't know how yet. So why don't we talk about some other aesthetics that Geom point will accept? So you've seen some pretty fancy scatter plots, I'm sure. And so you probably know that we can change the size according to some variable. So how might we vary size? Again, think of size as kind of an axis. What variable in this data set would be a good match for the size aesthetic, right? As one of these changes, size should also change. And I'm going to say probably the number of countries. So why don't we see what that gives us? Okay, that's kind of super interesting. Well, it's kind of interesting. Maybe it's not super interesting. It's kind of interesting. We can see Oceania, which only has 2 countries in it, Australia and New Zealand, if I had to guess. And you can see, for example, America, Europe, and Asia, roughly the same number of countries within each of those continents. Africa, as the biggest dot, has the most number of countries. Okay, all right, now we're getting somewhere, right? And there's another aesthetic that we can change too, right? We can change the color of these dots. So why don't I put this on the new line just to make reading it a little bit easier. And we'll put the only remaining variable. So this is our standard deviation. How much does it change by? Let's go ahead and run that and see what we get. So now we've encoded 4 variables into our visualization just by doing a dot plot, right? It may not have been a good idea to encode my variables in such a way. For example, I'm kind of looking at this and it's a little bit information overload, right? I have to look at like 2 different legends. I have to look at 2 different axes. It's just kind of overload. There might be a little bit of a better way to do it. For example, you know, instead of using the color aesthetic, maybe we could have another geom that was like a line segment that went from the average minus the standard deviation to the average plus the standard deviation. And you know what? Why don't we go ahead and do that? So to do that, we kind of have to have, actually, we need to have a line, right? So I know, for example, you don't know this yet, but I know this, that geom is called geom segment. It's a geom line segment. So why don't I say, okay, you know what? The color thing, that was a little bit too much. I'm not feeling that. It's a little extra. And instead what I want is a geom segment that goes from, at the low level, whatever this value is minus the standard deviation, and at the high level it goes from whatever this is to the mean plus the standard deviation. So we're going to have to do a little bit of fiddling here with our data set. And so let's go back and let's remember what we did. Let's recap. We started with our data set and then filter to 2007 and then only keep these 3 variables. Then the next things that we're going to do, I want you to do within these groups and summarize my data. And then please summarize by counting taking the average of life expectancy and taking the standard deviation of life expectancy. And now we're done with our summarizing within group. So once I'm done doing group by and summarize, I should say ungroup. And that's it. You don't have to type anything in ungroup. It'll let R know that from now on, everything that we're doing, just take this data set as it is. Don't collapse it down further any longer. And then I want you to add 2 new variables. And so I'm thinking we'll put some line segments right here. So what I need, let's go back to our help page, is I need an X end and a Y end. All right, that's kind of what I need. So let's see. So I have my X variable already, and I know that my lines are only going to go up and down. So what I need is X, Y, and Y end. So I have my X. I don't need to add anything like that. I have my Y. Let's call it Y start equals average life expectancy minus SD life expectancy. And my Y end equals average life expectancy plus standard deviation of life expectancy. Yeah, that's pretty much right? So we get 54.8 minus 9.63 equals 45.2. Okay. So that looks good to me. Let's assign it back to visualization. And let's rerun this, make sure that we still just got the, we took the color aesthetic out, great. And so now I want a Geoms segment, right? So here's where things get a little bit tricky, but since we're working with multiple Geoms, it's kind of worth doing tricky things, but doing them properly. When you put your aesthetic argument inside of the original ggplot call, all of your subsequent Geoms will automatically inherit that information. So that's helpful, right? So Geom point and segment already know that every time that they do something, they should look in this part of the code to find X and Y and size, if they use size. Right? Geom segment doesn't use size, as far as I know. So it doesn't look in there for that. But let's run this and see what happens as it is. Right? So it requires the following missing aesthetics because we haven't told it the proper aesthetics that we created up here. To create a line segment, you need more than what we've provided it. So why don't we give it exactly what it's looking for? On the x-axis, we know we still want it to be continent. And for y, we know that we created a variable to be the start of the y line. And we created a variable to be the end of the y line. And we put this in its own aesthetic call because, for example, you can see here for Geom segment, y differs for Geom segment than it does for Geom point. And so we have to tell them separately what their aesthetics are going to be. So let's go ahead and rerun that. Geom segment requires the following missing aesthetic, X end. I see. So Geom segment also needs to know where X is going to end. And that turns out actually to be pretty easy because it ends on the x-axis exactly where it started, right on continent. So let's run that again. Whoops. Okay. So it looks like we learned something interesting. First off, that Geom segment does take a size aesthetic. So maybe, why don't we do this? Why don't we move this aesthetic out of the whole ggplot thing, and we'll move it into Geom point, and let's run this again. Yeah, that's much better, right? And here's a quick tip. ggplot will plot things in the order that you give it to them. So I want these lines to be behind these dots, so I'm going to put it first. Okay, that looks pretty good to me. I think that looks pretty nice. I get a much better sense of kind of what my uncertainty is here by using different variables, by playing around with them, by understanding which aesthetics those geomes accept and which they represent well. So we've done this. We'll get to faceting in a second. So we'll say visualize summarized data. We'll save. So far we've kind of just been doing summarizing and plotting on kind of an understandable level. That is, you know, if you were really dedicated, you could just do this yourself in Excel, and we're not really tapping into the benefits of using R or working with large data sets. And what we really want is to handle our giant data set in some really interesting ways, right? What we really want is we want to be able to visualize many variables, and we want to be able to do so for many countries and perhaps even over time. So why don't we, instead of summarizing, why don't we just keep as many variables as we can, and why don't we try to plot them in as cogent a manner as possible, right? So let's start with our data. Okay, I want to keep my continent. I want to keep life expectancy and population. And maybe I want to keep GDP per capita. So let's start. Let's encode 3 or 4 variables into our next. See, what do we have left to do? Faceting. Okay, let's do faceting, right? I want to keep a few variables that I can encode into a cool chart like this. So let's start off. I'm going to select country, continent, life expectancy, and GDP per capita. And let's see what we get there. Okay, great. Right? And we have all of our, we have all of our years here, but we haven't really kept our year variable. So maybe I'll just keep year, as our maximum year. Okay, and now I have 1 observation per country, right? Let's go ahead. Faceting. Let's go ahead and put that in our viz object. We'll take a look at our viz object and look to see that it still makes sense. And it does. I'm getting some worrying trends here where my GDP per capita varies across orders of magnitude, but we'll cover that in future lectures. For now, let's just go back to visualizing this data set. So let's stick with a scatter plot. And let's do a few things. Let's try a couple different things. Our data equals viz, of course. We'll go to our aesthetic and we'll say, okay, on the x-axis, I think I want GDP per capita. And on my y-axis, I want life expectancy. And I want you to represent this as a geome point. But notice that we didn't do any summarizing. So now we should expect there to be 1 point per row. In this case, that means 1 point per country. Let's go ahead and run that. See what we get. Yeah, okay, that looks pretty cool, right? We also know from our previous example that geome point accepts more aesthetics than just X and Y, right? So why don't I go back to my data? Let's see what the head of that data looks like. And, you know, I think I actually do want to keep population. So let's keep population. And let's say size equals population. All right, great. And it's done some kind of scaling for me In future lectures, we'll do the scaling manually for good reason, because it'll be much easier for you to interpret your findings afterwards. But you can basically see, wow, look at that, right? There are several large countries here, right? These are countries by population. So big countries kind of in the middle around here. And this is essentially like a power law, right? That's what you're seeing. It's like a log linear relationship right here. If that doesn't make sense to you, no problem. But we've encoded 3 different axes worth of information here. GDP per capita on the x-axis, life expectancy on the y-axis, and population in size. But we have one more variable. We have continent. So why don't we say color equals continent? That's always a fun one. And look at that. I have my Lucky Charms bowl of scatter plots. And that's interesting, but it's really hard to pick out individual continents. What I really want is for ggplot to plot its own, each continent should be on its own chart. But I want all those charts plotted together, and that's where the use of facets comes in. So I'm gonna say facet wrap, and you'll see what we're doing here in just a second. And then I'm gonna say, okay, I want one distinct plot. So I'm gonna say facets equals per continent. And you have to put it in quotation marks for some reason. I can never explain to anyone why facet wrap works the way it does. It's completely unintuitive. So this is just one of those goofy things that you're just gonna have to learn. I'm sorry. And so let's see what we get. Okie dokie. This is kind of a lot cooler already, right? Because now I get to see the trends within each continent. You'll notice that it painted a plot, or it drew a chart for Africa, for the Americas, for Asia, for Oceania, sad little Australia and New Zealand all alone here, and for Europe, right? Actually, you know what? I don't really like Oceania being there. So I'm going to say filter continent does not equal Oceania. And that's much nicer to me, right? So unfortunately, this kind of does one thing, which is that all of these countries, it's not very useful to put them all on the same scale. So, you know, on the y-axis, that makes sense. They all go from about 40 to about 80. Not so much Europe, less so the Americas. But you can see there's quite a degree of variation in the African continent and even in the Asian continent. So what I can tell facet wrap is scales equals free, which is basically telling facet wrap, hey, you know, change the range of these scales dynamically as is appropriate for each of these individual plots. And when we do that, the relationships kind of come out a little bit more clearly. As you get more GDP per capita, you're more likely to observe a country to have a higher life expectancy. And we can see some bigger countries over here, right? Some big countries over here in Asia. And again, these are just kind of summary statistics. So this is not a causal chart in any sense of the word. We're not uncovering causal mechanisms here. We're uncovering associations. But faceting is very useful in doing that sort of thing. Okay, so why don't we go ahead, faceting visualization, and we'll call this one faceting data analysis. So let's go ahead and look at our data set. We're going to keep working with this data set here for a second, and we're going to recode some of our variables. So what do we mean by recode? Well, we have 3 continuous variables here, and color is kind of redundant once we have our facets, right? So we've encoded information about the continent in this chart in two ways. First off, the color varies by continent, but the facets also vary by continent. For what it's worth, that's actually good practice. You usually shouldn't encode color to one variable on its own, but you can ignore that for the time being, right? We have redundant display of information in color and facet. They're both telling us the same thing. And so, the real nitpicky part of me wants to say, okay, well, take color and do something else with it. And so we have these three continuous variables with life expectancy, GDP per capita, and population. But maybe I want to move down the ladder of measurement, and I want to turn one of these variables into a nominal or an ordinal variable. So why don't we start simple? Life expectancy to a binary variable. And let's see what we have again. We'll just say viz. So we're just building off of what we did right here, right? We're not starting from our full data set. There's no need to kind of do that right now. We're just going to use what we've got. And what I want to mutate here. I want to add some variable. Usually when you're recoding a variable, you don't want to override the existing variable. You want to create a new column. So I'm going to say life expectancy binary equals if else life expectancy is greater than the average life expectancy, then 1, or let's call it high life expectancy, otherwise low life expectancy. And let's see what we get. Yeah, right? Low, high, high, low, low. Great. And let's put this into another object called viz2. So I don't want to overwrite viz, because if I do that, the next time I run this, it won't work properly, right? Because it'll be looking at the new object that I saved and not the old one. So I'm going to name this something different. And note that you can't have spaces in your object names. So I use an underscore and I say viz2. Let's go ahead and let's look at viz2. See what we got? Yep, that's just what we made. And here's the great part about already having done this code. I'm just going to be a thief, and I'm going to copy and paste it here, right here. And I'm going to say, okay, well, the only thing we really wanted to change was the life expectancy, or the continent, right? Again, continent was a redundant variable here. We already accomplished our goals by putting each separate continent on its own facet. What I want to know now is which countries have above average life expectancy, which countries have below average life expectancy, and I want color to encode that variable. So let's see what we get when we replot this. Again, everything else will stay the same. We just copied this facet, so let's run that. Life expectancy binary not found. What did I do wrong here? So I copied and pasted, and I know that that worked, but it's looking for my data in the old object, not in the new object. So I have to tell it, hey, look in viz2. I've done some stuff in viz2, and that's where you'll find the variable. So let's go ahead and rerun it. Okay, that's kind of useful. That's kind of interesting to see, right? Okie doke. So we've recoded our variable in some interesting way, but maybe, this is not really a fine-grained category. Maybe I want a category that gives it to me in the lower third, middle third, and upper third. Right? So we regularly talk about, for example, middle income countries. Maybe I want to know about middle life expectancy countries. Let's see, make sure, right? But it would be really cumbersome for me to say, what is the middle third? Where does it start? Where does it end? Right? So let's start with viz2 again. Life expectancy to, we'll call this percentile. And one thing to point out is that when we did this mean life expectancy, we didn't do it within continent, right? If we wanted to do that, we would have had to have added group by continent. Whoops. Oh my gosh, I can't even type this morning. And then this, instead of mutate, would have to be summarize. If we had done that, then it would have given us the mean, but then we would have lost a lot of this other information, right? And there's a way that we could do that. We're just not going to tackle that right now. So for now, this will have to do. So instead, what we want is a way to split this life expectancy variable into thirds. But it would be really tedious of me to manually calculate what those limits are going to be. So first off, let's tackle this problem one by one. One, what are the cutoffs? 2, how do I apply them to my data? Okay, well, there might be a percentile function. Nope. Maybe there's a quantile function. Haha, look at that. There is a quantile function. Let's see what it says. The generic function quantile produces sample quantiles corresponding to the given probabilities. The smallest observation corresponds to a probability of 0, and the largest to a probability of 1. Okay, so that's kind of useful, but it's not that useful. Often, I find it more useful to look at the first 2 or 3 arguments that you pass to the function. And this is actually really useful, right? So x, what we're going to pass in is a numeric vector whose sample quantiles are wanted. Yes, that is what I want. So we're going to give it life expectancy, and we also need to tell it the probabilities, a numeric vector of probabilities with values in 0 to 1. So if I'm looking for thirds, that's exactly what I'm looking for. And sequence, let's see what sequence does real quick. Sequence 0, 1, 0.25. Okay, great. That's terrific, right? That kind of gives us its sequence. The function starts at 0, goes to 1, and then it prints out something every 0.25, like a step, right? So I don't have to go in, for example, and write like, oh, quantile data life expectancy probs equals C 0, 0.25, 0.5. That's tedious and boring. And I might die of boredom if I have to do that, right? So we know we can use the sequence function to do that. And why don't we go scroll down and look at an example? Perfect. Right? This will be useful if I'm a student, for example, and I need to see how things are working. I'll just go through and I can just copy this code and run it just as I did with sequence, and we can go from there. So let me think about what I need real quick. Okay, I need quantile for sure. And then I need to tell it life expectancy. I'm going to say, get me quantiles for this variable. And since we're doing this outside of a dplyr chain, right? Since it's not starting with data pipe, we kind of have to do it this way for now. But this is just to test the function first. And then let me scroll back up to, here we go. And I can say, okay, I need my probabilities. Sequence from 0 to 1 by 0.33. Let's see what we get. Yep. That's pretty much what I'm looking for, right? Okay, great. So I have, actually, let me look at sequence, right? Because it's giving me 99%. I'm not sure that I want 99%. Ooh, here we go. We can do length out rather than telling it the step. So why don't I just do that instead? Length out equals 3. Yeah, that's much better. Well, that's almost better. I need length out 4. Yep, perfect. That's what I'm looking for. Great. So we have kind of all the information we need right now to turn our life expectancy variable into 3 ordered categories. And so I need a way to apply these quantiles, these buckets that I calculated, to this variable, and then to produce another variable kind of like this, right? So I know that this variable is called cut. Look at that, convert a numeric to a factor. That's very useful. So why don't I try that out? Let's see what our viz variable looks like again. Viz2. We're going to chain it. We're going to say mutate because I want to create a new variable. And I'm going to say life expectancy factor, let's call it, equals cut. So I'm going to have to tell it what variable I want it to cut, life expectancy. And then we already did all the work of telling it what the breaks are. But here, I don't need this viz2 thing, right? And I'm going to put this on a new line so that I can see it a little more easily. And let's see what happens when we do that. Okay, so it definitely puts it in the correct categories, but these categories aren't very useful to me in an analytic sense, right? Like, yeah, I know it's between these two numbers, but I want you to call it something other than those two numbers. So luckily for us, cut takes a labels argument. So we can say, okay, well, I know that there are 3 categories. So I'm going to say low life expectancy, medium life expectancy, and high life expectancy. And let's see what that produces. No, not quite. What did I do wrong here? Oh, I see. I put the labels argument inside of my quantiles argument. So that's not correct. Let's find where my labels argument ends, and we have to pull it out by 1 level. Let's rerun that. And yep, there we go. That's perfect, right? So let's go ahead and put that back into, I think we'll call it viz3. It's getting a little cumbersome at this point, so I should really rethink how I do this kind of assignment. But let's go ahead and look at viz3, see what we get. And like the thieves we are, when we go back and copy the same ggplot code, and remember to change it to viz3, and we need to change our life expectancy factor rather than a life expectancy variable. And let's see what we get. Yeah, cool. All right. So you can see some countries really vary across our 3 categories. All 3 categories show up within Asia. All 3 categories show up in Africa, all 3 in the Americas, and 2 out of the 3 in Europe, right? This is kind of an interesting way to do things. We've encoded more information without kind of overloading ourselves with that continuous scale. Right, so great. So we've done if else, we've done cut, and so we've recoded variables down from a continuous variable to 1, a binary variable, and on the other hand, we coded it down into an ordered ordinal variable. right? And again, you can do all kinds of cleanup tasks like we did with labs, for example. We could do like labs, and we can say the title should say something like life expectancy versus GDP per capita with factor. I don't know, do something like that. And we can do other things as well to make this chart look prettier. But in general, we've got the basic visualization down. We've really honed in on what it is that we were trying to show, or we explored some interesting patterns, right? We might want to manipulate this data in the future so it doesn't look so goofy. And we'll get to how we do that in the next module or two. But for now, why don't we call it a day today, and why don't we summarize what we learned? So one of the first things we did is that we loaded our data set, right? We pulled in just our very simple, really 2 libraries. This one just had the data in it. We loaded our data, we looked at it. We looked at the structure of our data by just pulling out one country. And we got a good sense of, for example, where the variance happened in the year variable. So why don't we just go ahead and start from scratch, and we can just run all of these. We did a basic visualization of life expectancy over time. We played with some alternative geoms. We looked at geom line and geom point. That was pretty cool. And then we started doing some very basic analysis. We said, okay, well, what's the average life expectancy overall in this data set? And then we said, okay, well, what's the average life expectancy for a given continent and the standard deviation and the number of countries in that continent? We did all of those things with the group by and summarize, very powerful commands. Then we visualized our result in this kind of point and standard deviation, line range and dot visualization. This is a generally useful way of visualizing point estimates like the mean and our uncertainty, which is kind of standard deviation, but you can find this method useful across a number of different applications. And then we started looking into facets. We said, okay, what is a facet? And we said, okay, well, it's this kind of separating out individual plots based on some variable. In this case, we said 1 plot per continent. That turned out to be very useful. And then we looked at recoding our variables into, for example, a binary variable. Which countries have high life expectancy, which countries have low life expectancy. And you'll see that every time we add one of these aesthetics, it shows up as its own little legend over here. There's its own little guide, so it tells us how to interpret these different colors. Lastly, we did something a little bit more complicated. We said, what if I want more than 2 categories? What if I want 3 categories? And we calculated, for example, the quantiles. If there were specific cutoffs that I might want to use, I could specify those by just saying probs equals and then just passing a set of those numbers. But I did that. I did the percentile or quantile way of doing things, and then I plotted that with 3 instead of 2 categories, and it looked very cool, I think. So that's what we've done today. We did a few interesting things. We learned how to recode variables. We simplified. We made choices about how to measure things. We also summarized. We looked at the mean and standard deviation and N, or counting summary aggregation functions. These are going to be very, very, very helpful for you in your final paper. And at this point, if you haven't found a data set yet for your final paper, I'd encourage you to start looking. And if you have found a data set, then start playing around with some of these functions, right? Start doing group by counting and mean and standard deviation on the appropriate variables and see what patterns you can find. And finally, we looked at a few new types of geoms. We looked at geom point and geom line. We looked at aesthetics outside of just X and Y. We looked at color, we looked at size, and I think that's all that we looked at today. But important to note that we recognize that geoms don't just vary by X and Y, they can vary by lots of other variables. And finally, we looked at faceting. Now, we don't always want to use faceting, but in this case it was appropriate because we had a small number of categories and it really revealed something interesting about the data. So now that we're done with lab number 2, I will of course make this code available on Canvas, and you are prepared to tackle assignment number 2. I'm sorry, this is lab 3. You'll be tackling assignment number 2. If you have any difficulties at all, I would encourage you to put it away for a little while, come back to it, spend some more time on it. If you still have trouble, go talk to your classmates and see if you can work it out together. If you still have trouble, come to office hours that I hold and the TA will probably hold as well, or you can just email me with questions that you have. So best of luck. I'm looking forward to seeing the output of your assignments, and I'm looking forward to seeing you in Lab 4.